Okay, so we are diving on lesson 4, talking about sine law and cosine law applications. And the reason why this is called the application is because it's not just, here's a triangle, solve it. There's some kind of the word or some kind of context in this situation. So it's very situational. Now, before we get into this one here, we have to talk about some stuff with kind of angles that we have. So complementary angles are considered, two angles are complementary if they add up to 90 degrees. They complement each other, they add up to 90 degrees. So if this is the angle here, okay, now you can look at it in two different ways. You can look at it, read the angle from bottom up, which is 55 degrees, or you can look at the angle from vertical to this line. So what do you think this angle would be? If this is 55, this angle would be 35 degrees, right? Yeah, that's correct, yeah. Sorry, I'm cutting people off. Go ahead, explain.
Oh, because it's a right angle, so it's automatically 90 degrees, and complementary angles are, if they add up to 90.
Yes, absolutely. So 55 plus something will give you 90. Well, that gives you 35, right? So you can go 90 minus 55, no, yep, is equals to 35 degrees. Awesome. Now, we could read it from horizontal down or from vertical up. Okay, so they're telling us this is 78 degrees. How big is this angle up here? Or how can we figure it out? So if this is 90 degrees, the L shape is 90 degrees. This one would be 12, yeah? How did you think about 12? Yeah, 90 minus 78, that gives us 12 degrees. 12 degrees, fantastic. Okay, so complementary adds up to 90. Now there's another kind of angle measurement relationship. It's called the supplementary. Supplementary, and what does supplementary say? Two angles are considered supplementary if they add up to 180 degrees. Okay, so 180 degrees, we can read this angle from horizontal turning this way, it's 122. But if we can start here and then go up that way, how big is this angle on the other side? What's that? 58. And how did you get 58? 180 minus 122 is 58 degrees. Yeah, excellent. Now looking at this one. If this is 19 degrees, how big is this angle right here? 169, and you got that, or 61. It's because it's 180 minus 19. Okay, it's 161 degrees. Okay, so there are two things in there. It's called supplementary when it adds up to 180. Well, we could put that on our formula sheet. Put a star there so that we know what to put on our formula sheet. Okay, good. So let's take a look at this part. Example number 3. It says here, Tariq sees an airplane flying away from an angle of elevation. Oh, angle of elevation. What's that mean? And Hillary, who is 8.2 kilometers away from Tariq, sees the same airplane towards her at an angle of 8 degrees. Calculate the distance between Hillary and the airplane. So the great thing about this is that they have a context, they have kind of a story behind it, or a story, but at the same time they have this picture. Now, sometimes it might not have a picture, so we have to create a picture based on the information. So let's see if we could match this context, the story, with the picture, the illustration. So it says here, Tariq sees an airplane flying away from him at an angle of elevation of 23 degrees. Now, angle of elevation, what's angle of elevation mean? Look at the word, what's the root word for elevation? Right. Elevation would be going upwards, right? So the word elevate means upwards, right? And upwards from horizontal. From horizontal. Or from the horizon. So if this is the horizon or the horizontal line, it will increase. It's like looking up, right? Looking straight, that's looking horizontally. But then if you start looking up, that's your angle of elevation. You're looking straight up. So this person is looking up at the plane. And then Hillary, who is 8.2 kilometers away from Tariq, okay, so that makes sense there, right? Sees the same airplane flying towards her, coming towards her. And when she looked up, angle of elevation, again, it's 8 degrees. So this is her, right there, looking up, and it's 8 degrees. The question is, calculate the distance between Hillary and the airplane. Well, this is Hillary and the airplane. This is what we're looking for. Here's the question. What's our strategy? What's our strategy? How can we figure this out? Sine? Okay. Sine law? Okay. I'm not saying yes or no yet. Okay, I'm giving some people to kind of think about it first.
Sine, get that third angle to get that complete sine.
Okay, now you're kind of adding on to her thinking, and then now you're like saying, let's figure out this angle first, and then you're saying sine law. Okay, okay, interesting. I'm not saying anything yet. I'm gonna let you think about it first. Okay. So, yeah. Now since I gave you an opportunity to kind of think about it first, yeah, we could say, yes, we got these two angles in here. We don't have a complete ratio. This is what I'm thinking out loud. Can I use sine law? Do I have a complete ratio? No, that's not complete. Angle inside measurement, that's not a complete ratio. No. And then this one here, I don't have a complete ratio, right? I got a side but no angle. Nothing complete. So it seems like I can't use sine law. But there's a way out. There's some kind of a way out. Because what Delmar said, hey, I can use rule 180 in this situation. I got two angles here. I can figure out the third angle. So the third angle is 180 minus 23 minus 8. So how big is that angle? Okay. It's going to give us 149 degrees here. 149 degrees inside. inside. Now, yesterday when we were talking about this, some people didn't like what I had. Like, I used to go like that. Some people didn't like that. So, this is what they suggested. I saw one person do it. I said, oh, I think this is my match. You probably saw that on the thing. So that's instead of having circular thing, so they have that. And then here I got the angle, and then kind of matching it up with that. Okay. So let's sine law. Let's see. Okay, what's the sine law? Side, which is 8.2, divided by sine of 149 equals x divided by sine of 23. Sine of 23. And those are supposed to be equal to each other. So what are we going to do to solve for x? We're going to cross multiply these things. Cross multiply. So when we cross multiply that, what would we get? 8.2 times sine 23 divided by sine 149 equals x. So we're just going to take this and cross to multiply by 8.2. Okay. And then the x is alone. Now it's a matter of just figuring out this value. Okay. So I got to make sure that calculator is degrees. So I got 6.22, 6.22. Okay, so they used the measurement kilometers, the unit kilometers for that. So figuring out the x, that is 6.22 km, kilometers.
We have to say 6.22 or can we say 6.2?
We're going to just use 2 decimal places just because the exam are saying 2 decimal places. Matter of getting so that we're used to it. Okay? Take a look at example number 4. Example number 4, a triangular solar farm in Colorado, okay, has sides measuring 23, 34, 47. Determine the size of the smallest angle contained in a triangle. Smallest angle. Now, how do you even, they put the theta there. How do they know that this is the smallest side? Like, why can't it be up that one or this one? How do we know that this is the smallest angle?
Closer together. Because it's closer.
Yeah. Oh, it's closer together on a picture. Yeah. Okay. Yeah. Just by looking at the picture, this looks like smaller compared to those two. Yeah. Yeah. That's good. Yeah. Absolutely. Any other ideas? Now, if I bring out the scissors, what happens? The smaller the angle here, the smaller the side there, right? If I open it up, bigger angle, bigger side. Okay, so when we look at this one here, this is the smallest side. So that means this is the opening. I'll go like this, scissors. The smaller side. Okay, so smaller angle, smaller side. So how do we do that? Okay, I'm gonna refer to my cheat sheet here. It says here, when we have all three sides are given, we're gonna use this formula. So that's pretty easy, right? But we have to strategically put the angle A and the side A to where they belong. So if this is my angle, the theta, I'm going to call this angle A. So that means this side, 23, is side little a. And then this one would be B. And then this one is C. Okay. So let's write down a recipe. Cosine of angle A is equals to B squared plus C squared minus A squared divided by 2 times B times C. That's our recipe. We gotta follow our recipe here. So cos of angle A. Okay. B, we're gonna replace that with 34. 34 squared plus the C, which is 47 squared, minus A squared, so 23 squared. All of that is being divided by 2 times B, 34 again, times C is 47. Now, I think last time I said it to everybody, or last time when we were talking about this, I said to work out the top, work out the numerator, write down the number, and then work out the denominator, write down the number. So let's do that. Okay, so the numerator is 2836. Oh, you got a different answer? Oh, okay, let me recalculate mine. Cordell, do you need this? You okay? Okay, yeah, so it's 20 for 36, and then let's work out the denominator. Let's figure that out. So 2 times 34 times 47. Okay, awesome. Good. So cos of A is equal to this. Okay, what do you think the next step that we're gonna do? Divide. Excellent. So we're going to divide these two numbers. 2836 first. 2836 divided by 3196. Okay. Now that's going to give us 0.88. That can't be an angle. It's too small, right? That's too small. So what are we going to do next?
Second function cos.
Yeah, second function cos inverse. And then instead of retyping that 0.88,
0.88.
yeah, I got a 0.88. Instead of retyping the 0.88, I'll just go cos inverse answer. And then I'm going to get angle A of 27.46 degrees. Yes? Did everybody get that one? Good. Awesome. So you comfortable with our strategy? This is all three sides given. The only thing that can solve that is a cosine law.
What is the answer?
27.46. Yes? Is that what you thought?
Just write it down.
Oh, okay, sure. Okay, let's take a look at example number 5. Luxor Hotel in Las Vegas is shaped like a pyramid with a bright light beacon shooting up or out of the top. Cynthia is a contractor who wants to bid on a contract washing the exterior of the building. She needs to know the length from the tip of the pyramid to the point of the base. So we're looking for this one here. Tip of the building down to the base. The angle of elevation from Cynthia to the top of the pyramid is 20. Okay, angle of elevation again. Angle of elevation means from horizontal, like looking straight, and then looking up, right? Elevation means up. It's 20 degrees right there. She's standing at the point 250 feet from the base, so that's that one. And the outer wall of the pyramid makes an angle of 5 degrees there. Okay, good. So calculate the length of the exterior of the pyramid. So we're calculating for this part. Okay. Now, if you look at this triangle alone, we don't have a lot of information. We just have one angle, one side. That's it. Well, that's not enough information to figure out that. So, any thoughts on how we could?
Can get the other two angles.
We can get the other two angle, and how? What are you kind of thinking about? Can you?
180 subtract 35.
Okay. So where did that 180 subtract 35 come from?
Your supplementary angle.
So when you look at this part here, okay, this is what he's talking about. So he has this angle in here. I'll draw it out so that you can see it. This is 35 degrees. We're trying to figure out this angle, which is that one. So it's going to be 180 minus 35. So 180 minus 35, does that equal to 145? 145 degrees. Okay. Is that, can I use that now to solve for this information? Okay, so any ideas?
You need that other angle to have a complete pair.
Yeah, we need this top angle to complete the ratio of side and angle. So that would be, what would it be? 180 minus, now we're looking at the triangle as a whole, minus 20 minus 145. So this tiny sliver there is going to be 180 minus 20 minus 145, and that's a tiny sliver of angle there is 15 degrees. Okay, so we had to kind of figure out some other pieces so that we can figure out the missing information. I'm gonna get a different pen in here so we can see the pairing. Okay, so this angle is actually paired up with this side. Okay, because it's such a weird triangle, and then the 20 degrees is paired up with the x. Okay, because it opens up to the x. Now it's going to be a sine law because it's a complete ratio of side and angle. So 250 divided by sine of 15, and then x divided by sine of 20. We're going to cross multiply this. Cross multiply. So x 250 20 divided by sine of 15. Okay. What is that supposed to equal to? Let's figure it out together. Oops. Hmm. 330.37. That's for our x value. So 330.37, because we're talking about the side, it's going to be in feet. So 330.37 feet. Okay, is that good? We'll probably finish example 6 together. Okay, we'll see how that goes. So the kite shown in the diagram below is going to be made out of fabric. The person cutting the fabric needs to know the length of the short edge of the kite, AC right there. Determine the size of AC given that AD, this length here is 80, CD is 65, from C to D, 65, and angle BDC. And when we talk about angle, it's from B, D, C. So that's this angle right there. Now what other information is shown in here?
Well,
So if this is 65, do you see the tick marks there? What does that mean?
equal.
They're equal, right? That means this is also 65. What about these two? There's a tick mark on both sides here. That means AC and AB are equal to each other. But we don't know what that is. So if that's equal to each other, so that means this 40 degrees could be split up also equally. If the sides are equal, then that means the angles are also equal. That makes this 20 degrees. This is 20 degrees. Okay. This is no good for us because we don't have a strategy for a quadrilateral. But we do have a strategy for a triangle. Okay, what do you think this, let's focus on this one triangle.
It'll be cosine.
It would be cosine. Well, what makes you think it's cosine?
You got the sandwich going on.
You got the sandwich going on. You got this. If people who are non-mathematicians are like listening to our conversation, just happen to kind of click and it's like, what sandwich are they talking about? Must be lunchtime. Yeah, 20 degrees. The angle is sandwiched between the two given sides. Okay, so what's formula that we use? Okay, so this is the formula to use. A squared equals to B squared plus C squared minus 2 times B times C times cos of A. Okay. So now you're probably thinking, well, A is up there, but then this is D. So what's up with this? Remember, we're focusing on this triangle here. We're going to call this angle, this would be your angle A, or angle theta. Okay? It's just that they've already labeled A, B, C, and D here. So A squared, which is this part, would be 80, equals 80 squared plus 65 squared minus 2 times 80 times 65 times cos of 20. Has to be 20. So let's go ahead and calculate that piece. did you get 852.196? Okay, that's quite a huge number, right? 852. But really, that's a squared. So what do you think is the next step? What do you think? Square root, yeah. To get rid of the squaring, we gotta take the square root. Absolutely. So square root that. So it's 29.19 cm. Okay, so I think I'm gonna pause right there, and then we'll continue next time to finish up example 7 and example 7 and 8. Okay.